let's have a look at question 9. This is a moments question. Let's get started. So a plank AB of mass M and length 2A rests with its end A against a rough vertical wall. So because it's a rough vertical wall, so that would be uh, two forces here. So let's call the vertical one R1 and then the horizontal one R2. And then the plank is held in a horizontal position by a rope. One end of the rope is attached to the plank at B, and the other end is attached to the wall at point C. So basically, this string is holding the plank AB. And then, so because we only care about the turning effect of this plank AB, yeah, so we only need to look at the force act on AB. So the tension will act on this plank. So, and of course, there'll be another tension opposite to this one in the equal and opposite direction, but it's not to act on AB. Is so we don't need to worry about that one. So we only need to label this tension here, because only this tension act on this plank AB. And also, um, which is vertically above A. So, and then a small block of mass 3m is placed on the plank at P. So because the mass is 3m, so that means the weight has to be 3mg. Where AP is x meters, which is already labeled here. And then the plank is in equilibrium in a vertical plane, which is perpendicular to the wall. The angle between the rope and the plank is alpha, which is also labeled in here, where tan alpha is equal to 3/4. All right, so as before, we show a little triangle. So let's call this one alpha. And then tan alpha is 3/4. That means opposite has to be 3, and the adjacent has to be 4. And there's 3, 4, 5, within the hypotenuse has to be 5. And then sine alpha has to be opposite over hypotenuse, 3/5. And then cos alpha is equal to adjacent over hypotenuse, so it's 4/5. And then they tell us the plank is modeled as a uniform rod. So if it's uniform rod, the center of mass, which is X right in the middle. So mg should be right in the middle. So let's label it here, mg. And then the block is modeled as a particle and the rope is modeled as a light insensible string. So use the model, show that the tension in the rope is 5 mg times by 3x plus a over 6a. So we're looking for tension. So in this question, we have R1 we don't know, and R2 we don't know, and tension we don't know. There are 3 unknowns. So in this case, we always take the moments at this point, the corner, yeah, where R1 and R2 is, because the moments, if you take moments on the same line as the force, so then the moment for that force, that two force will be equal to 0. So we don't need to consider those two. Yeah. So then it's only tension we need to consider about an mg and 3mg. So basically it's only one unknown if we take moments at point A, because moments for R1 is on the same line as point A, so the moments will be equal to R1 times by 0, because it's the same line, so the distance equal to 0. And then so does R2. So if you're looking for R2, the moments of R2 about point A, that'll be R2 times 0, because it's on the same line. Yeah. So therefore, it's only tension, mg, and 3mg we need to worry about. So again, because it's in equilibrium, clockwise is equal to anti-clockwise. So mg and 3mg, that would be clockwise, because this go like this way. Yeah, that's clockwise direction. And then for the tension, if we draw a circle here, so we can see tension, let's go this way. So that has to be anti-clockwise. So first we write clockwise is equal to the anti-clockwise. So mg, the moments is always force times by the shorter distance about the point we take the moments on. Yeah. So that'd be mg times by its shortest distance, which is just this length. And we know mg is right in the middle. So it's just A. and then plus 3 mg times by the shorter distance. So the shorter distance from point A to 3 mg is this length, which is just same as x. So times by x. And then that will equal to the anti-clockwise moments. So tension times by its shorter distance. So shorter distance is always a perpendicular distance. So we draw a line from point A to the line of tension. Yeah. So this would be the shorter distance. It's not about like how long this force is. Yeah. So we always extend the line, and then you're looking for the shorter distance from the point to where that force lies on. So this shortest distance is what we're looking for. And then we know AB is 2A, and this is alpha. Clearly, that would be the opposite. So that would be just 2A times by sine alpha. So that would be all the moments we have here. So now we just have to solve this. So to solve this one, we want to work out tension. So we need to make tension as a subject. So straight away, we can do mg times by A, and then plus 3mg times by 3x. So we can see mg is the common factor, and we also have mg here, so we can factorize our mg straight away. So that would be 3x left here, and then a left here. So that would be 3x plus a. So we already get most of it. Yeah. And then we divide by 2a sine alpha for both sides. So we have 2a sine alpha in the denominator. And we can change sine alpha into 3/5, which we already work it out on top. Sine alpha is 3/5. So we have 2a times by 3/5. And then we can just times by 5 for both top and bottom because we have a fraction inside the big fraction. So if we don't want that, we can times by 5 for both top and bottom. Then times 5/5 will cancel out. So it's just left with 5 mg and then 3x plus a all over 6a. So which is the same as part A. Then part A is done, 3 marks. Let's look at question B. So it says the magnitude of horizontal component of the force exerted on the plank at A by the is 2 mg. Yeah. So basically, they're just talking about R2, the horizontal component, this one. Yeah. So if they say vertical component of the force exerted on plank at A, then that would be R1. Yeah. But this time they say the horizontal component of the force exerted on the plank at A. So that'd be just R2 they're talking about. And then they tell us the force is equal to 2 mg. Okay. So for this type of question, it's always two equations, one for moments, one for force, because it's equilibrium. Yeah. So we already used the moments, so now it's time to use the forces to set up the equation. So because it's in equilibrium, so that means force go up is equal to force goes down, and the force go left is equal to force go right. So because almost all the forces here is either in the vertical direction or the horizontal direction. So only tension is not. So let's resolve that either in the vertical or horizontal direction. So this is a vertical component and this is the horizontal component. So that would be the opposite. So that would be tension times by sine alpha. And this would be tension times by cos alpha. So two equations. First equation would be up equal to down. So R1 goes up, and then tangent sine alpha goes down, and then also goes up, and then mg plus 3 mg goes down. So that would be the first equation. And then left equal to right. So force go to the left-hand side, that would be T times by cos alpha, and then force go to the right will be RT. We already know it's 2 mg. So that would be two equations we're talking about. And then we're looking for x in terms of A. So that means we only need to use this one. So tangent, we already work it out from part A. We can just use it. So 5mg times by 3x plus a, and then over 6a. And then cos alpha, we already know, which is equal to 4 over 5. And then that's equal to 2 times by mg. We don't use the first equation because we just don't know what R1 is. Yeah. So in the second equation, we know everything. We know 2mg, we know cos alpha, we know tangent, we work out in part A. That's why we use this one. Yeah. So now just simplify. We're looking for x in terms of A. So we try to make x as a subject. But before that, we simplify everything first. So we have mg on the left-hand side and also mg on the right-hand side. We can just divide by mg for both sides. So mg will cancel out. And then 5 divided by 5 will become 1. So 5 over 5 will cancel out. And then we can multiply by 6a for both sides. So we will have 4 times by 3x plus a is equal to, so times by 6a, that would be 12a. And then divide by 4 for both sides, we'll have 3x plus a equal to 3a. So that means 3x is equal to 2a, then x is just equal to 2 over 3a. Then we have x in terms of a, which is another 2 marks. So let me just write it here. Later on, we need it later. Let's have a look at part C. So the force exerted on the plank at A by the wall acts in the direction which makes an angle beta with the horizontal. So basically what they're talking about is the resultant force of R1 and R2. Yeah. So the force exerted on the plank at A by the wall, so it's just the resultant force of R1 and R2. So R2 is just the horizontal component of the force exerted on the plank at A. And the R1 will be the vertical component of the force exerted on the plank at A. Yeah. So because we don't know where the direction of that resultant force originally, that's why we resolve it into R1 and R2. Like it could be in any direction. It could be like in here, or it could be in here. We don't know. But we know it has to be, we definitely can resolve them either in the vertical direction or the horizontal direction. That's why we just use two force R1 and R2 to represent it. But in this question, in part C, now they want us to work out the direction. So we definitely need to work out where the resultant force is. So we already know R2, which is 2mg. So now we need to work out R1 to work out the resultant force. So to work out R1, we need to use the first equation. So R1 plus tangent, we know is 5mg times by 3x plus a over 6a. And then times by the sine alpha, which is, okay, 3 over 5 here. So it times by 3 over 5. And that's equal to mg plus 3mg, that'll be 4mg. Then simplify this, we will have R1 plus, so 5 over 5 will cancel out. And then divide by 3 for both top and bottom, then this 6 will become 2. So we have mg times by 3x plus a over 2a equal to 4mg. And then don't forget in part B, we already work out what x equal to. So x equal to 2 over 3a. So we can just use it straight away. So R1 plus mg times by 3x, which is 3 times by 2 over 3a plus a over 2a equal to 4mg. And then 3 times by 2 over 3. So 3 over 3 cancels out. So just 2a left. So 2a plus a is 3a. So we have mg times by 3a over 2a equal to 4mg. So then R1 is just equal to 4mg minus, so a over a cancels out. So just left with 3 over 2mg. So then R1 is equal to, so 4 is 8 over 2. So 8 over 2 minus 3 over 2, that'll be 5 over 2 mg. Now we work out the value of R1. So now we know R1 is equal to 5 over 2 mg. So goes up like this. So 5 over 2 mg. And R2 horizontal 2 mg. Then the resultant force has to be this one. That's the resultant force. And we're looking for like the angle beta, which makes an angle with the horizontal. So that's the force, that's the horizontal. So this would be the angle beta. And they want us to work out tan beta. So then tan beta is equal to opposite over adjacent. So mg over mg cancels out straight away. So we're just left with 5 over 2 over 2. So if you times by 2 for both top and bottom, then this 2 over 2 cancels out. So just 5 over 2 times is 4. So 5 over 4. Then that would be the answer. Tan beta is 5 over 4. So another thing need to be careful is, so sometimes you won't get positive values. It could be negative value. So what I mean is, so if eventually you work it out, R1 is equal to, let's say, negative 3 mg, then how you sketch this, it should be 3 mg goes down. So because force is a vector, so if you have positive value, it just means it's the same direction as your original direction because you draw a vertical line upwards. So you assume to be positive. So if you have a positive value, it has to be the same direction as you labeled goes up. And if you have a negative value, then that would be the opposite direction as you assumed before. So it should be goes down. Yeah. And then 2 mg will be here. So that will be the resultant force. Yeah. And then that will be the angle we're looking for. Yeah. So like R1 and R2 could be in any direction. It's not necessary R1 has to be positive, R2 has to be positive. It could be both positive or negative. So if eventually you have like R1 is equal to, let's say, positive 4 mg, and R2 is equal to negative 3 mg. Then how you sketch this, it should be look like this. So R1 is vertically up 4 mg. And R2 is negative. So negative has to be go to that side. So because it's a triangle, you need to make them connected, like end point and starting point connect each other. So 3 mg should be go this way. So the resultant force will go like this. Yeah. Then this would be the angle we try to find out. Yeah. So the point is it can be any direction possible. Yeah, it's not always in the first quadrant like this. Yeah, it could be in the second quadrant, in the third quadrant, or in the fourth quadrant. Depends the positive or negative of each forces. Yeah. So which means the resultant force originally it could be in any direction. Could be like this, could be like this, could be like this, or could be like this. It could be in any direction. We don't know. But we know it doesn't matter which direction the force is, we can always resolve it into one vertical, one horizontal. So that's why for this type of question, we always just write as R1 and R2, one vertical, one horizontal. The last section. The rope will break if the tension in it exceeds 5 mg. So part D says, explain how this will restrict the possible positions of P. You must justify your answer carefully. So we already know what tangent is. Tangent is 5 mg times by 3x plus a over 6a. And then the tension will break if the rope will break if the tension in it exceed 5 mg. So that means as long as the tension less than or equal to 5 mg, then the rope will not break. Yeah. So that's how we set up the inequality. And then we just have to solve it. So divide by 5 mg for both sides. Then you just one left. So times by 6a for both sides. Then 3x plus a has to be less than or equal to 6a. And then minus a for both sides. We have 5a here. So x is just less than or equal to 5 over 3a. then that's it. You just have to write down the final statement because 3 marks. So this will give you 1 mark, and then the walking out will give you another mark, and you need another final statement. You just say, for the rope not to break. Then the block cannot be more than 5 3A from point A. Then the question is done. Yeah. So this question would be 13 marks. So that's quite lots of marks. So it'll always be one moment question come up. So just keep practice on it.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.